sebelum kita buat calibration, kita kena pastikan dia punya pH yang perlu digunakan semasa calibration dilakukan. Untuk alat ini kita perlukan pH 7, pH 4 dan juga pH 10. So di sini kita sediakan ketiga-tiga pH yang diperlukan. Okey, kita akan ambil probe. So kat sini kita akan lap secara perlahan-lahan. Hanya letak sahaja di hujung tisu. Dan kita akan gunakan yang pertama sekali adalah pH 7. Kita akan tekan kepada calibrate. So dia akan keluar calibrate 1. Bila nilai dah stable, kita tekan read. Okey. Lepas tu kita keluarkan probe untuk dibersihkan sekali lagi. Dan lap sekali. pH 4 dan kita tekan calibrate.
Calibrate point tu.
So dia akan keluar calibrate yang kedua, di mana ia adalah sama 4 dan 0. Bila bacaan dah stable, kita akan tekan read. Okey, so dia akan keluar 4.0. So kita akan beralih kepada buffer yang ketiga. Kita akan lap. Calibrate dan akan keluar calibrate yang ketiga, iaitu 10. Bacaan dah stable, kita tekan read. Okay, stop. So, kita buat simpanan untuk elektrod. Kita kena bersihkan elektrod dan kita lap macam biasa dan disimpan di dalam 3 molar HCl. adalah pen pH meter, di mana kita akan mengambil bacaan daripada sampel yang memenuhkan kawasan berkenaan.
Itu nama apa?
Okay. So, bacaan ini diambil. So, kekurangan dia adalah volume sampel kita akan berkurang setiap kali kita akan gunakan pH meter ini.
Hi, I'm Shahida. Today I will show you how to run the UVs spectrophotometer. But before that, I will elaborate or I will tell you what you need to know before you run the UVs. Okay, for today we are using a Thermo Scientific Genesis 10 UVs. So because of this instrument is UV visible, so the range of wavelength is around 190 nanometers to 1100 nanometers. Okay, this is double beam instrument, UVs double beam. Okay, it consists of 6 cells in here. So one is blank and then the rest is your sample or your standard. Okay, after you already know your instrument capability, the range of the wavelength, and then you need to know what type of sample that's suitable to run using a UVs. Okay, you can run a sample, environmental sample, which is such as methylene blue in wastewater, or you can run test a metal, okay, in environmental also. Okay, that is a type of sample. Okay, so after we already know our type of sample and our instrument capability, we need to know what type of cuvette that can be used to analyze using these UVs. Okay, usually we have 3 types of cuvette. One is plastic, second is glass, and third is quartz. For the plastic, the range is only a visible range. So if you have a sample that the wavelength or it absorbs the wavelength in the UV range, you cannot use a plastic cuvette to run your sample. And then the second one is glass. Glass cuvette can run a visible range also, but the visible range is up to 340 to 900 only. If you have less than that, you cannot use the glass cuvette. Okay, the last one is a quartz cuvette. This quartz cuvette is very expensive, but you can run the sample from the UV and until the visible wavelength, which is 190 to 1100. Actually, cuvette, quartz cuvettes can run up to 2500 nanometers. Hi, so now I will show you how to run the UVs. But first, we need to prepare our standard or our sample. For today's test sample, I will use methylene blue for this test experiment. As you can see, in this methylene blue, we can see here maximum absorption in water is at wavelength 663 to 667 nanometers. Okay, so these samples I dilute with deionized water in 10 ml of water. Okay, so this is our cuvette. I'm using a glass cuvette for this test experiment. So as you can see, the glass cuvette has two surfaces. One is frosted surface and one is clear surface. So please beware, don't touch the clear surface, just touch the frosted surface only. This is to avoid any transmittance light during the experiment. Okay, so right now we just pour the sample into the glass. So first you need to turn on your instrument. So let the instrument initialize, and then once the instrument is ready, then you can run your sample. So for today, I will show you two tests, which is scanning and also basic ATC. Okay, so for this instrument, there are several test type or test method that can be performed. Okay, for example, you can perform a standard curve analysis using this instrument. Okay, but for today, I will show you on this scanning and basic ATC. So for our previous sample, methylene blue already put in the cuvette, and also we need a blank solution. So blank solution is water, because I use the deionized water to dilute my sample. But if you use a solvent, so you need to use a solvent that used to dilute your sample as a blank. Okay, so right now we go to scanning, and then we just put the measurement, start wavelength and stop wavelength. Because of this, I know already the wavelength is around 663 to 667 when it diluted in the water. So I will use the scanning is around 400 to 800. So how you want to enter the wavelength is go to start wavelength and then enter, and then just put your desired wavelength, enter again, and then stop wavelength, where is the wavelength will be stopped, same, enter, put the wavelength and then enter. So this one I want the measurement mode is absorbance. Okay, okay, after all of this is finished, we can run our sample. Okay, so we need to put our sample in here. Okay, this is our sample compartment. As you can see, there is B, which is blank, 1, 2, 3, 4, 5 compartment. Okay, so blank we need to put in here. The light will go through like this. So you need to make sure your clear surface is facing like this. Okay, so if you are wrongly put the frosted surface like this, then the measurement is wrong, because there is a lot of interference for the light. Okay, so make sure this, and then your sample will be like this, same also position. And then just close your compartment, run sample. Okay, now we need to do a baseline collection. Okay, so collect baseline, but first we need to make sure the cell is at blank position. So to make sure there is a blank position, we just hit this one blank, and then this will appear blank. Okay, and then we do a blank correction. After finish the collect baseline, and then you can measure your sample. But first you need to change the cell position to cell 1. Okay, once the cell 1 is appear here, and then you can press measure sample. This scanning mode is used to scan the wavelength, and then we can find the lambda max using this scanning method. As you can see, this is the absorbance, and then this is the graph. To find where is the lambda max, which is the maximum absorbance, we need to click tabular. So here we scroll down until we get the highest absorbance. So the highest absorbance is around 2.617. So the wavelength is 666. So as you can see at the bottom is 663 to 667, means this one is within the range. Okay, so we already have the lambda max. Now if you can run all the standard solution. Okay, next test is basic ATC. Okay, so go to the test, and then click basic ATC. Okay, as we know that our wavelength is 666, so we set our wavelength is 666, and then just click enter. Okay, make sure your wavelength is correct. Okay, so first we measure blank. So the blank will be 0. Okay, now we measure the sample. So just change the cell position to cell 1, and then the absorbance will appear here directly. Okay, so this is the simple test to run a UV sample if you already know the wavelength. If you don't know the wavelength, you just can use scanning, choose a lambda max, and then take the lambda max and put here, and then just run 1 until 5 sample using this basic ATC. So that's all. Thank you.
Hello, this video is about how to handle a high-performance liquid chromatography, HPLC. This video is brought to you by the Faculty of Industrial Sciences and Technology, University Malaysia Pahang. What is HPLC? HPLC stands for High Performance Liquid Chromatography. This is a technique or an instrument that could perform chemical separation. In HPLC, Chemicals can be separated based on the interaction of the analytes with the stationary phase, which is in the column, and the mobile phase, which is the solvent. Analytes that have strong interaction with the stationary phase will migrate slower throughout the column as compared to those analytes that have weaker interaction with the stationary phase. Because analyte with strong interaction with the stationary phase moves slower, it will be separated from the analytes that have weak interaction with the stationary phase, which move much faster. As you can see in the figure on the right, at t equals to 0, the sample is being injected into the column. In those sample contains the analytes of interest. The analytes will be pushed by the mobile phase, and the degree of interaction of the analyte with the stationary phase will determine whether the analyte will move at the speed of the mobile phase or slower than the mobile phase. The interaction of the analyte with the stationary phase slows down the movement of the analyte or the migration of the analyte throughout the column. Eventually, as it reaches the end of the column, the analytes are separated because they move at different speed and thus reaches the end of the column at different time. This is the act of separating analytes. There are actually several types of HPLC, and each type may have several modes. However, the most used type of HPLC is the partition chromatography, and the most used mode in partition chromatography is the reverse phase chromatography, in which the stationary phase is nonpolar and the mobile phase is polar. The reverse phase partition chromatography allows analyte to be separated based on the polarity of the analytes. Analytes that are polar will be eluted first because it will have a weak interaction with the nonpolar stationary phase, while analytes that are nonpolar will be eluted later because of the strong interaction with the nonpolar stationary phase. After separation is being conducted using HPLC, we will get an output. This output is called the chromatogram. It is basically a graph of signal versus time. In the chromatogram, you will be able to see what are the components that are separated from the mixture. In this figure shows the separation of three compounds, compound A, B, and C. Compound B is eluted the earliest, meaning that it has a less interaction with the stationary phase, while compound C is being eluted last because of the stronger interaction, and thus it moves slower throughout the column. A good chromatogram is basically a chromatogram that has all of the components well separated between each other. That is, the peaks are not overlapping between each other. Narrow peaks are highly desirable as compared to broad peaks because narrow peaks allow better resolution of the peaks and also the possibility of packing a lot of peaks in a single chromatogram. This schematic diagram shows the overview of the component in HPLC. From here, you can actually get a clue of the process that's happening in the instrument. First and foremost, there is the pump. The pump will withdraw solvents from the bottle and supply those solvents into the instrument. Then we have the injector port. This is where the sample is being injected. The injected sample will then enter the HPLC column. Here, the separation takes place. The separated analytes will then be detected by detector, and the signal will be sent to computer for data acquisition. Solvents and analytes that have been detected will then go into the waste bottle. Now, Let's open the HPLC in our lab and look at the components. The narration hereafter will be conducted in Bahasa Melayu.
Saya akan terangkan sedikit tentang HPLC yang ada di FIS. Dan kita ada dua jenis HPLC di sini, iaitu HPLC ada auto sampler dengan detektor yang berbeza, dan yang special ada fraction corrector. Berbanding yang ini ada dua detektor tapi tiada auto sampler. HPLC sistem terbagi kepada mobile phase, pump, ada injector, column dan detektor. Baiklah, yang pertama kita mulakan dengan mobile phase. Mobile phase yang kita gunakan biasanya adalah air, acetonitrile, metanol dan juga buffer. Okay. Bagi air yang digunakan mestilah ultra pure water ataupun deionized water. Metanol dan acetonitrile mestilah HPS grade ataupun GC grade, dan buffer mengikut metod masing-masing. Dan solvent mestilah difilter menggunakan filtration set. Okay. Filtration set ni kita akan letakkan dengan membran filter dan disambung pada vacuum pump. Selepas difilter, mobile phase perlulah digas selama 15 hingga 30 minit, dan kemudian kita masukkan ke dalam botol, skop botol untuk diletakkan di sini. Seterusnya kita pergi pada bahagian pump. Pump berfungsi untuk membawa kita punya mobile phase ke dalam solvent system kita, dan untuk control flow rate yang kita perlukan. So di sinilah dia akan control. Okay. Bagi solvent yang baru ditukar, kita perlu push pump dengan cara buka push ni dan longgarkan, kemudian tukarkan flow rate kepada 3 hingga 5 mil per minit untuk clearkan solvent yang ada dalam saluran ini dengan yang solvent yang baru. Baiklah, ini pula adalah bahagian auto sampler dan injector. Okay, sampel yang sesuai untuk digunakan pada HPLC ialah sampel yang non-volatile sampel. Dan sampel perlulah dimasukkan dengan wire ini. Sebelum dimasukkan, mestilah filter menggunakan Schilling filter. Kemudian masukkan ke tempat auto sampler, dan ini adalah injector. Maksimum volume bagi injector ini adalah 20 microlit per sampel per run. Kemudian bahagian yang paling penting adalah column. Kolom yang ada di FIS ialah yang kolom yang biasa, iaitu C18 dan NH2. NH2 biasanya digunakan untuk karbohidrat ataupun sugar. Dan detektor yang digunakan untuk NH2 kebiasaannya adalah refractive index, iaitu kita gunakan yang di sini. Ialah untuk kolom C18, kita biasa sebagai general ataupun common column yang banyak digunakan secara meluas. Okay. Bagi kolom, kita juga memasang guard column yang berfungsi sebagai protector kepada kolom. Dia akan menapis dan menghalang impurities daripada memasuki kolom, dan akan melindungi kolom kita daripada impurities dan boleh menyebabkan kerosakan. Baiklah, kolom terdapat pelbagai jenis yang terdapat di pasaran dan kegunaannya adalah bergantung kepada aplikasi yang kita mahukan. Okey. Sebagai contoh, bagi pembelian kolom C18 ini disertakan juga dengan datasheet ataupun kolom guideline, dan di sini ada terdapat kolom karakteristik dan guidelines yang berkaitan seperti maximum pressure, maximum temperature, jenis mobile face yang sesuai, pH yang sesuai, cara penjagaan dan lain-lain lagi. Okay, seterusnya kita pergi kepada bahagian detector. Detektor yang kita ada ini ialah Diode Array Detector, iaitu DAD, di mana kita menggunakan deuterium lamp sebagai lampu yang kita gunakan untuk menghasilkan UV. Okay. Stop. Jenis detektor yang biasa digunakan bagi HPLC adalah DAD dan juga RI detector. Fungsi bergantung kepada sampel dan kita punya projek analisis yang diperlukan untuk mendapatkan sesuatu compound. Okay, bagi DAD, kita menggunakan deuterium lamp untuk mendapatkan UV range 190 hingga 400. Manakala RI detector biasanya digunakan dengan NH2 column, iaitu untuk sugar karbohidrat analisis. Dan bahagian terakhir dalam HPLC ini yang ada adalah fraction collector, di mana dia berfungsi sebagai isolator pada compound di dalam sesuatu sampel. Metod HPLC terbahagi kepada dua jenis, iaitu isokratik dan gradient. Metod isokratik bermaksud ratio mobile phase yang kita gunakan dalam analisis atau metod itu tidak berubah. Manakala bagi metod yang gradient pula, ratio bagi mobile phase akan berubah dalam masa analisis tersebut. Ini adalah contoh bagi metod isokratik, di mana hanya satu ratio yang digunakan sepanjang 10 minit dengan flow rate 1 mil per minit. Manakala bagi gradient, kita boleh tambah seperti ini. Contoh seperti ini.
In order to control the process happening in the component of the HPLC, we need to rely on the software that comes with it. Through the software, we will be able to set up the chromatographic condition for the separation. The chromatographic condition is also known as the method for the separation. The software will also allow us to view the result and also generate reports.
Ini adalah interface bagi ChemStation, iaitu software yang kita gunakan dalam HPLC Agilent ini. Bagi injector, set up injector, dan injection volume bagi injector ini adalah maksimum 20 microlit. So kita masukkan berapa injection volume yang kita mahukan. Manakala di sini pula ialah untuk setup pump. Di sini kita akan set up flow rate dan stop time, solvents, sama ada isokratik atau gradient. Seterusnya, di sini adalah setup kolom thermostat, di mana kita juga boleh menggunakan temperature pada kolom kita. Tetapi temperature adalah bergantung kepada jenis kolom yang seperti yang telah dinyatakan dalam spesifikasi kolom. Sama ada kita nak guna boleh digunakan atau tidak digunakan. Kemudian setup DAD signal. Okay, di mana di sini kita boleh set 1 hingga 8 wavelength dalam satu-satu masa. Okay, wavelength yang diperlukan di sini adalah 190 hingga 400 nanometer. Ini adalah contoh result yang telah kita run. Bagi HPLC ini, data ini adalah kuantitatif dan bukannya kualitatif. Bagi menentukan sesuatu compound, kita perlu run standard untuk dipadankan dengan retention time daripada sampel kita. Dari result analisis ini, kita boleh mendapatkannya dalam bentuk PDF dan akan terhasil result sebegini.